Hello student. In this video I am going to discuss about a few clipping algorithms. Before that, try to revise whatever we have tried to learn in the last video. That is about clipping. Clipping is only thing is about removing the portion of output primitives. Primitives means here the thing you are going to display, output primitives on the display of your monitor outside clipping window. So removing those portions of output primitive which might be outside the clipping window. So there might be a difference between clipping window and the world view, and during the world view we set the clipping window to clip the object, and the clipped object can be only shown in the display. There are two types of approaches, like we can clip during scan conversion, check each pixel against clip limits, means every point will be mapped from the world view to the your viewport, and whatever pixel is not inside the viewport will be clipped out. That is like a scan conversion procedure. And second one is clip analytically. Then scan convert the modified primitives. So there is two-way approach. One is we can do the scan conversion procedure, and line by line we'll try to understand which pixel is going to be inside the clipping window or which will going to be outside the clipping window. But second one is that we try to directly analytically clip the object, then we try to draw the thing by converting those clipped portion that is going to be displayed using scan conversion procedure to display the object in the monitor, or you can say viewport. So we're going to discuss these topics in this clipping part of this course. It will take 2 or 3 videos might be, because a bit of long or very important part of this topic, and it needs to be we need to go very deep into these points, because these algorithms are a bit tricky also. So there are lots of clipping algorithms exist, but main point is that identifying the parts of the objects that will be inside the window, that is the main purpose of the algorithms. So everything outside the clipping window is eliminated from the scene description, that is not scan converted. So here you can see whatever is outside the window will not be described, will not be stored in the scan conversion for efficiency. So that is why these algorithms provide the analytical technique. Second one, that is we try to find out which part of the object will be kept in the window, and then we try to describe those things and we can convert those things, so that we does not go for every other points of your world view for efficiency, which will degrade the efficiency. Actually, if we go for scan conversion of every point, because for a larger picture there might be crores of pixel might be there, so you cannot go for every points so that we can decide whether that point is inside or outside. So that is why these algorithms will provide us one theory, that is first we understand which part is going to be clipped, first understand that part, then we convert those points using scan conversion. So here you can see, to clip the point, it means to find a point is inside or outside, we need to follow these two equation. That is this is window x window minimum, this is xw max, means the x value of the point should be less than equal to window maximum and less than equal to window minimum of x, and y value should be less than equal to window maximum of y, and window minimum of y should be less than to the point that you are going to clip. So point clipping is nothing, just we need to find out whether that point is inside or outside of the window. So to find that whether the point is inside or outside, we need to just think about these two equations. Means whether this point xy is inside the window or not. So this is very trivial thing about point clipping, so we don't need to go for more understanding. This is basic thing, and point is that we will go more deep in case of line clipping. And first, to understand the line clipping, we will go through the first algorithm, that is Cohen Sutherland algorithm. Clip a line against each edge. So clipping the line against each edge of clip region. So clip region might be different shape, but for our purpose we are taking as a rectangle or might be square. So for every region or for every boundary of the clip, we'll try to find or we'll try to clip the lines. So if both endpoints, try to understand these points, very important. If you clear about this point initially, it will be very easy to understand later on. If both endpoints of a line outside, means suppose this is the window, so one line might be, suppose this is the line, so here both endpoints are outside. Okay, so this is one, discard the line and stop. So there you might arise a question, why this? It might be like that. So we'll discuss that as a disadvantage in this case. But let me go through the procedure. If both endpoints inside the window, suppose this is the edge or line, if both endpoints inside, continue to the next edge. So if there is another edge, we try to go for the next edge. If one edge or one endpoint is in, one endpoint out, stop the line at crossing point and continue. So next, suppose this is the line. So one endpoint is outside, one endpoint is inside, then stop at the cross section. So that is the procedure, but we'll find some drawback in this case, but let me go through it first. Here, suppose this is the line, this is the line. Okay, so first we'll try to stop, or we'll try to think about the line, these endpoints in case of this boundary. Then we stopped that part. Okay, that part is deleted. Then we'll try to execute for that boundary. Then that part is deleted. Then we'll try to execute for this part, this boundary. First this one, second this one, third this one. Okay, first, second, then third. So all the points are inside. If it stays outside, then we can go for more, this one also, this side also, or this side also, but already the line is inside. So that is a conceptual view of the Cohen-Sutherland algorithm, but let me take through more of this concept. So here some cases lead to early acceptance or rejections. Here you can see if both endpoints are inside all edges, then we can directly include that. That is early acceptance. If both endpoints are outside one edge, that is the point. Okay, outside one edge at least. So this line, both endpoints both endpoints is outside one edge of the clipping window, then that is early rejection. We can directly reject that. But suppose this is a line, then we cannot say that that line, that though these points are outside the clipping window but not outside of single edge. Okay, both endpoints are not outside of single edge of the clipping window. Okay, so that is initial idea about early acceptance and early rejection. For Cohen-Sutherland line clipping algorithm, they have tried to divide the window in some bit format. So based on determination of completely invisible lines, segments, by doing more tests before intersection test. So they try to do more tests before doing the intersection test. Means before trying to find the intersection point with any other boundary of your clipping window, they try to do more tests to find out which part or that line will be inside, or we are going to need we are need to going to segment the line, or we can keep the line inside the clipping window or not, like that. So here you can see they define test bit. There are 4 bit 1, 2, 3, 4. The left of the left border. So this is left of the left border. That is these points. This is 1, this is 1, this is 1. So that is bit 1. And bit 1, if it is 1, then we can say that that is left of the left border. And second bit is right of the right border. Second bit is right of the right border. Here you can see this is left, right. Second bit, here you can see second bit is 0. Here you can see second bit is 1. So it means that when it is 1, then it is right of the right border. When it is 0, then this is, at least we can say that if all the bits of the second bit are 0, then we can at least say that lines, that part is in right left of the border, but if the bit 2 is 1 but left is 0, the first bit is 0, then we can say at least that the part of the line segment is right of the right border. Bit 3 is below the bottom border, that is this 3 bit, this third bit. Okay, so when it is 1, then we can say that that point of the line is below of the bottom border. So this is left border, this is right border, this is bottom border, this is top border. And bit 4 is for top border. Top border, that is 1, 1, 1. So when we say that 1, 0, 1, 0, then we can say that that point is in the top also, in the right also. Here you can see if it is 0, 0, 1, 0, then that point of the line is only right side of the border, right of the right border. And if it is 0, 1, 1, 0, then it means right and bottom of the border. If it is 0, 1, 0, 0, then only we can say that it is bottom of the border. Okay, but if all the 0, then it is inside the border. So when bits, also called out bits, are defined for start and end point of the line segment, a single bitwise operation defines the visibility of line segment. How? Okay, so try to understand this first, what bit defines what, and according to that the algorithm will proceed. So This is the example. Bit 1, suppose bits x1 y1, bit 2 b2 x2 y2, suppose 2 points x1 y1 x2 y2. If b1 equal to 0, b2 equal to 0, then both endpoints inside. Else if line is completely outside, ignore it, else needs further calculation. So that is the point. Point is that if both bits of x1 and y1, x2 and y2, all bits are 0, then the line would be inside the window. That is a trivial accept. But if not 0, means some part of the bits are 1, then that point, that line might be here also, line might be here also, or here also. So in that case we can directly ignore. In those cases we can ignore, but we cannot ignore this case. In that case we might need further calculation. Okay, here you can see b1 or b2 or is 0. So if you do OR operation between b1 and b2, both point inside the clipping window. How we can say? Here you can see, suppose if both endpoints inside clipping window, suppose if 1 0 0 1 or 0 0 0 1, if we do OR, then what we will get? 1 0 0 1. So then it means this is not 0, so that will not be equal to 0. Then we cannot say that that line is not inside the window. But this will happen, b1 or b2 will be 0 if and only if the line is inside the clipping window. Then obviously trivially we'll accept that. But if we say b1 and operation, b2 not equal to 0, if and only if line endpoints are in the same half space defined by an edge of the clipping window, reject. So again, if you do perform 1 0 0 1 and suppose 0 1 0 1 means this side, if we do AND operation, this will be 0, this will be 0, this will be 0, and this will be 1. And again, for another example, if you take these two edge, these two part, 1 0 0 0 and 0 0 0 and 1, then what will happen if we do AND? It will become 0 0 0 and 0 if we do AND operation. Then it means that it will not be equal to 0. It will not be equal to 0 if and only if the line endpoints is in the same half space. Same half space defined by an edge of the clipping window. So that case might be in that border also, in that border also, in that border also. So it will not be equal to 0 if the line stays like that, like in that way, or in that way. In that case it will not be 0 if we do AND operation. But if that line crosses the boundary, like in that way, then the AND operation will be obviously 0. So in that case we will go for further calculation. Here you can see it says that else subdivided line into two segments at the point where it crosses the clipping rectangle edge. We need to divide the line where it crosses the boundary, crosses the clipping rectangle edge, and reject segments outside the clipping edge. So our calculation will be where to clip. We have to clip that point in that part. So how we'll clip that will follow. So that is the part it is explaining. If we do OR operation, then trivially accept. If we do AND operation, in case of non-zero, it will be reject. In case of zero, we'll go further. Process clipping boundaries in order and clip a section of the line during the process. Use the bits calculated before crossing test. So before every crossing test, we need to apply the bit test. Okay, use slope intercept. You need to understand, or we need to use the slope of the line to find the cross section. Here you can see, consider the line AD. Consider the line AD. Point A has outcode. Point A has outcode or the bit code 0000 because this is inside the clipping window, and point D has outcode 1001 means this is left and this is top 1001. The line AD cannot be trivially accepted or rejected. Obviously, if we do AND operation, it will become 0. Then obviously we cannot trivially accept or reject. D is chosen as outside point. So first D is chosen as outside point because A is already inside. Its outcode shows that the line cuts the top, chosen top and left edge. So its outcode here 1001 shows that this is top, this is left. So that is what it is saying, that the outcode shows that the line cuts the top and left edge. The bits for these edges are different into outcodes because you can see 0000 and 1001. So here difference is only in case of top and left. That is why that line will be obviously going to cut top and left edge. So let the order in which the algorithm tests edges be top to bottom. So we'll try to go from top to bottom. The testing process. Algorithm tests the edges from top to bottom, then left to right. So our algorithm will follow in that procedure. Algorithm will follow like what? It will go from top to bottom because top is first. If it is 1, then left is 1 initially. That is why left to right. The top edge is tested first. Top edge will be tested first. Top edge is this one. A line AD is split into lines DB and BA. DB and BA. Though it has cut the left edge, but we have chosen top because the first bit is 1 first. That is why we are choosing this part first. But if we are going to need to find out this cross section, we will do that in the later part. But our priority is that we need to go for top one as the bit is 1 difference from the output of 2 points of the end points. So we'll try to go from top. That is why we have divided the AD line in 2 parts, that is DB and BA. Line BA is trivially accepted. Line BA will be trivially accepted. Both A and B have outcodes of 0. So here you can see that whether the line on the endpoint is this endpoint B is on the edge of the clipping window. So we have to set the outcode, or you can say bit code of the B as 000. So line DB is inside. Line DB is in the outside half space of the top edge. So line DB is outside half space of the. If BA is inside, then obviously BD is outside of the top edge. Then we get rejected. This DB get rejected. Okay, so that is the procedure. So here after rejecting the upper part. After rejecting the upper part, we try to find the cross section. So to find the cross sections, we need to understand or we need to use the slope of the line. Slope of the line equation is y2 minus y1 divided by x2 minus x1. So repeat for border. This has to be repeated for border, left, right, bottom, top. This is the initial conversation, that whether it is if we do AND, then we accept or reject if it is not equal to 0, reject and eliminate. If border equal to left or border equal to right, then we try to do this, or else we try to do this. If border test next for x1 y1 is this, update the line endpoints, else if this. So before understanding this more clearly, we try to go through an example. Okay, here you can see we'll try to go through this algorithm through this example. Here, suppose this is the line P and there is another point, that is 8 5. This is not feasible here, but this is 8 5. Okay, this is 8 5, 8 5. So first they test this part, bit 0 0 and bit 8 5. So what is the code for this? This is left but bottom 0 1 0, and here this is only right 0 0 1 0, not top not bottom. Okay, but this is bottom and left, this is bottom and left. So if we do AND of this, it will get, if we do AND of this, then we will get 0 0 0 0. So that is why 0 0 0. Then we try to find out the slope of the line, that is 5 minus 0, 8 minus 0, 5 by 8. So the left, for the left border, yp equal to yp equal to y1, okay, y1 plus 8 by 5, 1 minus 0. Here y1 equal to what? 0. So this is yp. Okay, so here you can see y1 is initially this one, this is y1, this is x1. So y1 is 0 and the slope, this is what the equation says, what in this one, this is x border x1. What is the x border? X border is 1. This is the x border, or you can say x minimum, and x1 is 0. So 0 plus 5 by 8, 5 by 8 is a slope. Here you can see m, this is the m, y1 plus m. So y1 is 0, border is 1, x1 is 0, slope is 8, 5 by 8. So yp equal to 5 by 8. So at this point will be updated. This point will be updated like this one, where x value will be same. X value will be the border value. X value will be the border value 1, and the y value is updated as 5 by 8, because we are going in that direction. We already know we are in the, as we are testing with the left boundary, our x value will be always 1, that is why 1, but our y value has been updated because of this slope, so it will become like this. Next we try to do right part. For this part, here yp for the right, not for this one, for this one. Here yp will be updated because y1 plus 5 by 8 7 minus 1. How? Here you can see this is in case of right same equation, in case of right also same equation y1. In case of here y1 will be what? Y1 will be what? 5 by 8, because we are taking left p1 has been changed to p1 dash, because this has been rejected, this part has been rejected for this equation. So here at this stage y1 is 5 by 8, slope is 5 by 8, and in that case as we are taking the right border, that is 7, because right border is 7, and minus 1 is what? That is x1. So to find out that point, we use y1, because this point has been updated from the left. Then we use 5 by 8 the slope, then we use the right boundary, that is 7, then we use x of the this point 1, which is the updated point. So we again update the right point p2, that is p2 dash 7 35 by 8. Then bottom case, in bottom case it will follow this equation. In else it will go else, it will go for else. Here you can see for bottom, this is the bottom. Okay, this is the bottom. For bottom xp, because in that case y will be fixed to x will be changed, xp will be changed 1 plus 2 minus 5 by 8 by 8 by 5. 2 is what? 2 is what? That y value, and what is the this 5 by 8 value? This 5 by 8 value is this one, and 1 is the this point. So from this point we need to find out the cross section. We are finding the cross section from this point. So our initial value of x is this one, and again we need to find the value of y. Okay, here we use the value of y, but we try to find the x. Here we use the value x 1, then y value 2 minus 5 by 8, 2 minus 5 by 8 into 8 by 5, that is this is the become 16 by 5. So our this point will become 16 by 5.2, 16 by 5.2. So top is p1 double dash inside, p2 dash inside, p1 double dash inside, p2 dash inside, so terminate. So ultimately our segment is this one. So try to go through again through this example how we got this. Okay, first try to eliminate this section using the slope. So you got this point, so depending upon this point you try to find this point using the slope again. After finding this point you try to find this point, and after finding this point you need to check this line is already, we can at every step we can check that, but for prominent view, for understanding, the checking statement has been done here only to check that whether the endpoints already inside the window or not. If it is inside, then we take that, we do not go for further calculation, but try to follow this equation. Equation is like here you can see in the previous slide, that is what if it is left or right we go for this, or it might be top or bottom we go for this. Okay, we go for this, so that is why we go for this for bottom case. But in case of left or right, we go for this equation. In case of top or bottom, we'll go for this equation. And every step, we'll try to update the point and do the border test. So here you can see again, fixed order testing and clipping causes needless clipping. So that ordering and the testing procedure do efficient job. We need not to go for needless clipping, like we can directly reject this type of lines. We can directly go for these parts, and also by doing testing we can directly go for point B, not for point C. But we can go for also C, because we are going from top to bottom. Okay. The algorithm can be very efficient if it can accept and reject primitive trivially. If clip window is large with respect to scene data, most primitives are accepted trivially. If clip window is much smaller than the scene data, also most primitives are rejected trivially, obviously, and it might be good for hardware implementation. So that is about Cohen Sutherland line clipping algorithm. I will try to explore the next algorithm in incoming video. And if you have any doubt regarding this Cohen Sutherland line clipping algorithm, please let me know, and try to do at least one example for better understanding. You will find lots of examples in the book also. Please follow that. And that is all about in this video. We'll try to go for Leon-Persky line clipping algorithm in the next video. Thank you.